this is Josh Keller. I'm the owner of NCE Exam Prep, and I wanted to share another little explanation video. This one actually didn't take place during our group tutoring, but the question of standard error of measurement was asked, and a question was presented. I can't remember which resource this question came from, but I actually answered it incorrectly during the group tutoring. I had mistakenly read it as asking about standard deviation, so I started even plotting it on the standard bell curve to try to explain it. And after reading it further, we fleshed out what it was actually about, which was standard error of measurement. And so I wanted to offer another video explaining standard error of measurement to try to offer maybe a more concise way of understanding it, as well as some solutions to some practice questions to try to clarify that. So here's an explanation of standard error of measurement that you might find helpful. Thanks. Okay, so let's talk about standard error of measurement. When we're talking about standard error of measurement, this is different from standard deviation. They are similar, and it seems like they're related, especially because we're looking at, we can kind of look at the bell curve to see how standard error of measurement is related. But essentially with standard error of measurement, we're trying to look at the reliability of a given score actually happening on a test. And so if we were to look at standard error of measurement for the NCE, for example, we might ask, what's the likelihood that someone's score is going to fall in a certain range? And so that's what standard error of measurement is going to say. It's going to say within 68%, there's a 68% chance that the score is going to fall between these two scores. There's a 95% chance the score is going to fall between these two scores. And so it just kind of gives us an idea of how to predict someone's scores across multiple different tests or multiple different exams if they're taking the same test. Okay, so let's look at a sample question. And then in the tutoring, there was a question related to this that I'll get to after I explain standard deviation, after I explain standard error of measurement. Okay, so here's a sample question from my practice exams. If a person obtains a score of 52 on a test that has a reliability coefficient of 0.86 and a standard error of measurement of 4, then one can assume these things. Okay, so for this, we need to determine what we need to know, what we don't need to know. The reliability coefficient is only telling us that this is a highly reliable test. The closer we get to 1, that's a more reliable test. If it was lower than that, it would be a less reliable test. And so we don't really need the 0.86 for this question to be answered, but let's look at the rest of the information. So let's plot what we know first. First, our raw score that we're given on this test is 52. Okay, so we're going to plot that right here in the middle because we're going to calculate on either side of the raw score using the standard error of measurement. So from there, we can look at, in general, a 68% confidence interval is our test score, which is 52, plus or minus 1 standard error of measurement. For a 95% confidence interval, we use plus or minus 1.96. And for 99%, we're using plus or minus 2.58. Now, when we're calculating these on the NCE, we're going to round. We're looking for a close enough answer. And so my guess is you're not even going to have to use this 99% confidence interval with 2.6 because most people aren't going to be able to just do that in their head. So if you have to do this, it's probably going to be with plus or minus 1 standard error of measurement or plus or minus 2. So using our raw score, which is 52, plus or minus 1 standard error of measurement, which is 4, we can see that there's a 68% chance that the score is going to fall between 48 and 56. That's our raw score minus 4 and our raw score plus 4, because that's the standard error of measurement is 4. There's a 95% chance that the score is going to fall between 44 and 60. That's 2 standard errors of measurement, roughly 2, right? So we've got 52 plus or minus 2 times 4. So 52 plus or minus 8 is 44. 52 plus or minus 8 is 60. And so that's how we have that range. And then I went ahead and calculated the 2.6, and that gave us 41.6 and 62.4. So again, I highly doubt that you're going to need to calculate that. So from there, we can look at the question answers and try to narrow it down to the best possible choice. So let's go ahead and plot those. So for answer A, 99% of a person's score will be between 44 and 60. So if we look at 44 and 60, we can see that that's 95% and not 99%. So we can probably rule out A as a solution. If we look at B, 68% of the person's scores will be between 48 and 54. So we have 48 here, one standard error of measurement below the raw score. And then 54, that's like half of a standard error of measurement above the raw score. But it's saying that 68%. Well, 68% would be one standard deviation below and one standard error of measurement below and one standard error of measurement above. See how easy it is to get confused between standard deviation, standard error of measurement. So this is not a good choice because 68% would mean that one standard error of measurement above would have to be 56 and not 54. Okay, so now let's look at answer C. 99% of the person's scores will be between 40 and 64. So here we can see that 40 is just below 2.6 standard errors of measurement, and 64 is just above 2.6 standard errors of measurement. Again, you're probably not going to have to calculate that out, but we can kind of guess that it's pretty close here. So this might be a good answer because that's right around 99%. Okay, but let's just rule out D to see if we're correct that C is the correct answer. So 95% of the person's scores will be between 48 and 56. Well, this is clearly not the case. 48 and 56 would be 68% of the scores falling between those. So 95% has a much wider range than that. So we can rule out answer D as the option. So the correct answer would be C, 99% of the person's scores will be between 40 and 64. And again, we're approximating. We're looking for the best possible answer. Even if we didn't calculate out these actual numbers, we'd be able to guess that of all 4 answers given, this would be the best possible answer. Okay, so let's look at the question that was provided in our group tutoring on Tuesday night. Going back to a blank chart here. So the question was, a respondent obtained a score of 33 on a test with a mean of 36 and a standard error of measurement of 3.5. The counselor concludes that there's a 96% chance that on any occasion, the respondent's score in this test would be between blank. So remember, with standard error of measurement, we're trying to determine the reliability that a score is going to fall within a certain range. If this respondent took the same test over and over and over again, we're predicting what the likelihood is that their score would be in a certain range. Okay, so we're given the answers here. Let's go ahead and plot what we know first. So our raw score is 33, and then we're going to look at the standard error of measurement, which is 3.5, and multiply that to give us each of these confidence intervals. So with a 68% confidence interval, we've got 29.5 to 36.5. Again, that's one standard error of measurement above and below the raw score. Around 2 standard errors of measurement. We're going to multiply 2 times 3.5. That's going to give us a range of 26 to 40. And then if we're doing 2.6, again, you're probably not going to have to calculate this. We've got about 24 to 42. Again, I calculated that out and approximated and rounded. But now let's look and see how this compares with the answers that are given. So answer A, 29.5 to 36.5, right? That gives us about 95%, 96% is what we're going for here. So if we look at 29 to 50, sorry, 29.5 to 36, that is not right there, right? So answer A would not be correct. If we look at, if we look at 32.5 to 39.5, 32.5 is above the raw score to 39.5. So that's not going to give us a 96% confidence interval. 26 to 40. So 26 to 40 is right where 95 or 96% is going to be. And then D, 29 to 43, 29 to 43, that doesn't give us in the range. So with our standard error of measurement, that interval is going to fall equally below and above the raw score. And so in this case, the answer is C, 26 and 40. So one of the questions was, why are we multiplying it by 2? And the simple answer is, when we're going for a 95% confidence interval, that's how we find a 95% confidence interval, is multiplying the raw score by around 2. Again, we're having to round here because we don't have calculators. And so that's just how we find it. For 68%, we're going for 1 standard error of measurement. For 95%, we're going for 2 standard errors of measurement. And for 99%, we're going for 2.6 standard errors of measurement. So I hope that this answers the question. Again, make sure that you're reading the question carefully and not confusing standard deviation with standard error of measurement. That's the mistake that I made when I first read it, and that's kind of what I had prepared for. You know, everybody, you know, is capable of misreading these things, and so it would give you a very different answer. And chances are they may have an answer on the test that matches that misunderstanding. So let me know if you have any questions about standard error of measurement. Feel free to post a question in the chat here or in the comments if you want to ask for some clarification, and I can make another video to help explain it. So hope that this clears some of the things up. Thanks.